Hello, in this video we're going to derive the compensated labor supply function, and we're going to look at solving for income and substitution effects from a wage change. So we have a utility function. It is a function of C, consumption spending measured in dollars, and L, hours of leisure. If we were to take the partial derivative of the utility function with respect to L, leisure, we would get the following result. So here's the marginal utility of leisure. And we can get the marginal utility consumption by taking the partial derivative of the utility function with respect to C, consumption. We're going to let the wage equal W. Non-labor income is going to be represented by V. And we're going to assume this person has 16 hours per day to allocate between work and leisure. So 16 equals H, hours of work, plus hours of leisure. Or hours of work will equal 16 minus L, hours of leisure. If you wanted to construct the budget constraint, the amount of consumption that the consumer can afford, C, equals a wage times hours of work plus any non-labor income, V. And with 16 minus L, we're going to plug that in for H. We have the following. So for utility maximization, we want the marginal utility of leisure divided by the wage to equal the marginal utility of consumption. In other words, the last dollar spent on leisure gives as much additional utility, added utility, as the last dollar spent on consumption. So substituting in the marginal utility of leisure and marginal utility of consumption. And we're just going to simplify this and solve it for C. We'll get C equals W times L. We're going to take this C equals W times L and we're going to plug it into our utility function. So where I have C, I'm going to plug in W times L. And since C is raised to the 1/2 power, W times L will be raised to the 1/2 power. Simplifying this, L to the 1/2 times L to the 1/2 power is L. And now dividing through by 2 times W to the 1/2, we get this result. The next step here, this is the last result from the last slide. Next step here is we're going to substitute out L for 16 minus H. So as I mentioned, you have 16 hours to allocate between leisure and work. So L can be thought of as 16 minus H. Solving for H, we have our compensated labor supply function. The ordinary labor supply, I'm not going to derive it in this video to save time, equals the following. So that's the ordinary labor supply and the compensated labor supply. Let's show how we can use these in a problem. So let's assume non-labor income is $10 and the wage is $10 per hour. So plugging those values into the ordinary labor supply, we get the utility maximizing hours of work at 7.5. This means the person is enjoying 8.5 hours of leisure in a day. In terms of consumption, we saw in a previous slide that C equals W times L. That came out from the utility maximizing condition. So W is 10 and L is 8.5. This person can afford $85 of consumption by working 7.5 hours at $10 an hour and then having $10 of non-labor income. So that's where the $85 is coming from. We're going to evaluate our utility function at a consumption level of 85 and leisure at 8.5 hours, and we get our level of utility here, 53.7587. If we evaluate our compensated labor supply function, okay, at these values, wage is 10, utility here being held constant at 53.7587, we have a value of 7.5 hours, like we found on top here. All right, now let's look at a wage change. So let's let the wage increase to $16. So we take our ordinary labor supply equation and evaluate it where W equals 16, and the consumer will work now 7.6875 hours. So the total effect of the wage change on hours of work. Before, the consumer is working 7.5 hours, now a little bit more. So the total effect on hours of work from the wage increase is almost 0.2 hours more work. Let's look at the substitution effect of the wage change. This is where we're going to use the compensated labor supply equation. So holding utility fixed, or real income fixed, at 53.7587 and allowing the wage to increase to $16, we get 9.28 hours. Okay, so the substitution effect idea here, the wage goes up, leisure becomes more expensive, so the person will buy less leisure and instead work more hours, and we see that here. So this is going to allow us to get the substitution effect. So the size of the substitution effect is this 9.28 minus 7.5. So before the wage increase, a person was working 7.5 hours, allowing the wage to go up, but holding utility, real income constant, this person would work 1.78 hours more. So that is the size of the substitution effect. In terms of the income effect is the total effect, or we get the income effect by taking the total effect equals the income effect plus the substitution effect. We know the total effect over here on hours of work, it went up by almost 0.2. We know the substitution effect here is 1.78, and so we need to solve for the income effect. So just moving some things around, subtracting 1.78 from both sides, we have an income effect that causes the worker to reduce hours of work by almost 1.6 hours. And that makes sense. The income effect tells us a higher wage leads to a higher level of income, so the consumer can afford more leisure, so the demand for leisure will go up and you'd want to work less. Overall, the substitution effect is greater than the income effect, so hours of work go up by, again, almost 0.2 hours. All right, that's it. I hope you found this video helpful.